Welcome everyone. Thank you for turning up. Actually, yeah, I was gonna close the door myself, but you sure? Thank you. I hope this bit's captured on recording for everyone to watch. Yeah. So thank you everyone. Thanks for turning up. My name is Gannon. I am a product manager here at Neo4j. Actually, I used to be a field engineer at Neo4j when I started 7 years ago, so 2015. That was a long time ago. Previously, you've heard about Aura in the previous session. I see a few faces still hanging around. So you might remember Aura Professional, Aura Enterprise, worked on those, worked on the launches of those. And now I'm responsible for AuraDS, which is our Graph Data Science as a Service. And that's what this session's about. Yeah, so let's begin. So I'm going to talk through what is Graph Data Science for those that don't know. I'm going to give an introduction to AuraDS. I'm going to talk about some integration options that you might want to think about, and what's coming next for the rest of the year as well. So what is graph data science? We like to conceptualize it as graph data science is when you want to answer questions not just with your data points, but with the connections themselves. So the interactions between data points is really important because you can have just individual data points that maybe represent customers or products. But actually what's really interesting is how do those customers interact with those products? How do these different entities actually interact? So we like to say that with graph data science, you can find out what's important. So like maybe who has the most connections? Or you might want to look for what's unusual. So who looks different to others, or what little bits of the graph look different in terms of topology. And you can then discover what's next using different techniques. So you can maybe do link prediction and find out who should be connected to these people. So I always like to start with improving outcomes, only because we talk about many different use cases, but I think the 4 things that I see very much used today a lot of the time, and hence why we've actually supplied some lovely demos as well for you to go after. So you can head over to the Neo4j product example repo. You can use these QR codes to actually go and interact with them. So we have a data set around detecting and identifying fraudsters, where we actually use real-world data to actually find fraudsters. We've got a data set for doing customer recommendations as well, so that uses Microsoft's Big Mind data set, which is Microsoft News, and we do recommendations on that itself. And we've also got a data set on resolving entities and entity recognition. You can then resolve entities and identities. And coming soon is going to be one on supply chain. So it's very much similar to the route optimization problem. So we like to say that doing graphs and graph data science is kind of a steps. You have these different steps that you can find value at. The first step is always to create this knowledge graph. And that's a lot of value from that alone. Just being able to connect these different entities, run Cypher queries, and understand more about your data and your data points. So you can write simple Cypher queries to find what patterns you're looking for. And this is pretty good if you're an SME. Now, the next step in finding value is kind of using graph algorithms. Things like PageRank, that's what made Google successful, where you can use unsupervised machine learning techniques to be able to identify associations, anomalies, and trends. And then taking it an even step further is using things like graph native machine learning. So you can use things like embeddings. How many people know about embeddings? Raise your hands. Couple of people, yeah. So like these are like the newest kind of craze, like Pinterest, other people like the fan group are really into these at the moment, and it helps with doing recommendations, etc. And I'm going to talk a little bit more about those a bit further on, but this allows you to train in-graph machine learning, and you can use models to then predict links and maybe even labels. You can predict labels and even missing node properties themselves. So we like to say Neo4j Graph Data Science enables contextual analytics and modeling itself. So when we talk about the Graph Data Science platform, we're really talking about a couple of things, but there's lots of bits to it. And I like to say that one part is the analytics workspace. So this is being able to take your data from the database or from around the web. You saw this morning where we took from BigQuery into the projections themselves, ran those algorithms in real time. And so you can then project these into memories, and you can create workflows and pipelines themselves. And you can also store and manage your models. So you get like built-in ML ops as well. And then on the other side is the robust graph algorithms machine learning methods. So these are things that you can compute topology with, build predictive models, and they're highly scalable and highly parallelizable into the billions of nodes. And we actually like scale test this regularly on tens and hundreds of billions of nodes. So in terms of like the techniques that we offer, we kind of categorize these into like 6 main areas. And at the beginning, you kind of have pathfinding and search, so things like breadth first search, depth first search. But you also have things like centrality and importance. I spoke about PageRank, but there's other bits like betweenness centrality and closeness centrality. You've got community detection, and with 2.1 we're releasing more algorithms themselves like k-means clustering and Leiden. And we've also got graph native machine learning. I spoke about node classification, link prediction, and node property regression. You can do similarity, so like Jacquard is probably something everyone probably knows of, but you can do k-nearest neighbors and other bits. And the most exciting part is graph embeddings for me. So like things like Node2Vec, Graph Sage, FastRP, those work really well and they're highly scalable and allow you to then take those embeddings and create, basically, take the topology of the graph, put it into embeddings, and then you can use that in other places. And we've got loads more other kind of auxiliary procedures as well, and I'll talk a bit about those in a bit. So I mentioned machine learning pipelines. We're actually just releasing AutoML within Graph Data Science as well. So you can build out your pipelines and you can say, hey, look, I want to do node classification, node regression, or link prediction. And then what we also do is we say, okay, well, go train it. And you say, hey, look, I want to run this trial 100 times to find the best model, and we'll find the best features for you to use and give you back the best highly performing model itself. And then once you've trained that model, you can persist it and store it within your model catalog and use that model to predict on new nodes as they come into the instance. So when we talk about self-managed GDS, it takes like a crew of people to do this. So it's not only the data engineers, the data scientists, the machine learning engineers, and the data analysts, but you also need DevOps, you also need IT folks in order to manage these instances themselves. And that's the reason why we created AuraDS, is to hopefully give modern data teams less stress, effectively, so that they can get on with doing their job, feature engineering, building machine learning pipelines, and not have to exacerbate all the resources within your organization. And so that's why we're introducing AuraDS. You get all of the features of graph data science with none of the administration itself. So it's a fully managed service that you can then deploy. You say, hey, look, go create this for me, go manage it for me, go keep it updated for me. These are optimized instances that are configured for graph data science that scale between 8 to 256 gig today, with 384 coming very, very soon, and we're busting the limits and keep on growing and giving you bigger sizes. As I said, you get all of the GDS features themselves. So you saw all the 65 algorithms and machine learning techniques, and we're constantly adding new algorithms and machine learning techniques daily. And we also do enterprise security. So this is encrypted at rest and in transit using at-rest encryption, but then with TLS 1.3 in order to transport that over the wire. So we made it super simple for you to get started from creation all the way to operation. And what I mean by that is we give you help selecting the most appropriate size instance. And I'll show you a bit later on with a GIF that shows you, hey, all you need to do is insert the number of nodes, number of relationships, and pick one of those algorithm categories that you want to get started with. The reason we do categories is because when you're doing data science, you want to explore, you want to try new things. You might want to do breadth first search and then try out depth first search. You don't have to keep on going back and changing your instance up and down. But because it is a fully managed service, you can scale up and down depending on your needs afterwards. It's easy to load data from in and around the web, or in and around the cloud, or from locally. So you saw this morning the data importer, if you want to take CSVs from your local instance and bring that into your AuraDS instance. Or if you want to use the new thing like the new data warehouse connector that was just released, you can use that to take from Snowflake, BigQuery, and other places, and bring that into your instance easily. Make it super simple for you to be able to interact with AuraDS. So we've just released a native Python client back in April when we launched, but there's other things like our other Neo4j drivers, and I'll show you those in a few slides ahead. As I said, I keep on saying it, you've got all the algorithms, all the machine learning techniques, and all of the auxiliary features. Actually, one of the favorite things about GDS is actually a procedure called collapse path. It's being able to create monopartite graphs, where your graph might have people and transactions to other people. You can use collapse path to say, let's create a monopartite graph of people to people. And that allows certain analyses easier to do rather than having to munge the data yourself. You can just say, collapse this path down to people to people. And in terms of operations, it's fully managed. You can scale up and down and do what you need to do without having to worry about those instances themselves. So this gets rid of a load of people from the picture. It makes it super easy for you guys to keep going, not having to worry, not having to send a support ticket to get your instance upgraded and all the rest of it. You can just do that yourself and manage it yourself easily. So there's two flavors of AuraDS today, and one's an early access program. But what's available today is available on GCP. So you get large instances between 8 to 96 gig, and you can pay either by credit card by going to neo4j.com, or you can head over to the GCP marketplace and buy it. You get ad hoc backups, which means that if you want to create checkpoints within your analyses so you can revert back, maybe you've loaded data source A, then data source B, and made a little bit of an error, you can switch back and create backups along the way in order to help you, and it's pausable too. In terms of the early access program for AuraDS Enterprise, you can then bust the limits above 96 gigs. So you get access to 384 in a few months or so, or few weeks, sorry. And you also get region selection if you need that for compliance reasons, or VPC isolation if that's a security requirement. You also get 24/7 Sev1 support, as well as negotiable contracts if you need it. So I like to talk about how do you integrate AuraDS, because I think it's really important because different data science teams or different data teams have different requirements themselves. And I like to think of it as a spectrum. And on the left-hand side, it's transient, and on the right-hand side, it's doing it all within the database itself or the instance itself. So what I mean by transient is when you use AuraDS to create your features, and then you take those features and maybe feed it into something else. Maybe it's like your TensorFlow pipeline. Maybe it's Vertex AI on GCP. And so it's being able to compute those graphy features and use those somewhere else. And then on the opposite end of the spectrum is just you're doing it all within the AuraDS instance. This is great for getting started really quickly because you can do all the machine learning techniques, you can create this feature engineering, and you can use that instance to then query serve up to other applications or other parts of your pipeline. I recommend that most people probably say transient, or sorry, centric, just because you've probably got a modern data pipeline already going where you have different tools, different parts of the ecosystem, and there are some pros and cons to both, or to all sides. So if you're looking at it from a transient perspective, you don't really care about the persistence of the AuraDS instance itself, but it's super simple for you to be able to plug into existing pipelines. But it does require specialized expertise. It does mean that you do have to have people that know about infrastructure and all the rest of it, and how do you connect all these different parts. It's harder to introspect because obviously once you're handing off to other places, it makes it a little bit difficult, but it does require a mature data pipeline itself. On the flip side, if you're using native, it's fully managed GraphML and GraphML ops as well. And you do get a potential faster time to production because you're not having to worry about gluing all these different pieces together. However, I will point out, I don't know what that was, the ML options are a little bit limited in themselves because, as I said, it's only like node regression, node property regression, link prediction, and node classification. From a centric point of view, you can plug and play into existing pipelines, you can introspect the components really easy, you get the flexibility of both worlds, and you get the full database capabilities, keeping graphy data in a graphy shape. So in terms of getting started with AuraDS, you can pay any way you want, as I said. So if you want to get started, head over to neo4j.com/AuraDS, or you can head over to the GCP marketplace. Or if you want to do contracts themselves, come speak to myself or some of the other people in the team, and we'll talk about all the options around AuraDS Enterprise. I mentioned it's easy to get started, so we give you help with selecting the most appropriate size hardware. So here we're just inserting the number of nodes, number of relationships, and then we're asking it to calculate and estimate. And we go behind the scenes, run the estimator functions for those size graphs, and what we do is we give you back an estimation that says, hey, if you want to run all the algorithms within this category, you're going to need this size. And so afterwards, maybe you say, okay, well, I don't want to do similarity. You can scale down afterwards, or maybe you say, I want to run embeddings, which require a bit more compute power, so you can scale up as well. Loading data into AuraDS, there's many options. You can use the Neo4j Spark connector, and that allows you to integrate maybe with your Databricks environment or your Google Dataproc environment. You can use the data warehouse connector to get things from from Snowflake, BigQuery, Redshift, Synapse. Or if you've got an existing Kafka connection, you can use Kafka to be able to move data around your estate and get that into AuraDS. We've also got the Neo4j BI connector, which allows you to then be able to inspect what's going on within your AuraDS instance and maybe present it in something like Tableau or Looker itself. And of course, we've got a suite of drivers that you can use. So things like Python, Java, JavaScript if you want, and Go as well. So I mentioned the new data warehouse connector. It does run on Spark. What it does is it uses Spark jobs to go and pick up your data from your data warehouse itself, bring that over into your Spark cluster, and then persist that into Neo4j, into your AuraDS instance. It's really simple to get started. If you want, you can head over to the GitHub QR code now, and you can actually download it, get started, give it a try. And it's really simple to configure and say, hey, I want these tables, and maybe you want to put some where clauses on it as well, and bring that over and load that into your database. Oh, this is where a GIF doesn't work. So this was a GIF that showed you how to migrate an existing instance. So what you can do is you can use the simple drag and drop interface within Aura. And what it does is it basically allows you to, oh, here it goes. It allows you to then basically be able to upload a dump if you're migrating an existing instance into AuraDS. However, there is a browser limitation, which is only 4 gigs can be loaded in. But if you do want to use larger size dumps, you can use the push to cloud admin command. So the push to cloud admin command, if you've got a Neo4j instance running, you can use Neo4j admin, and it says, okay, push to cloud. And so it allows you to automate your workflows. Maybe you're constantly throwing your data over so you can do data science on it. And this is nice and easy to do, and it's really simple. We've also got cloning within Aura itself within the platform. So maybe you have an AuraDB instance today and you want to start running some data science on it. So you can use the clone function to be able to clone between not only AuraDB and AuraDS or vice versa. And this is either into new instances or existing instances that you might want to use. And it's really easy to get started too. These GIFs aren't loading. I apologize, guys. It was meant to be a good GIF. There it goes. It kicks in finally. So we've got a ton of usage examples in the app as well as in your documentation. And they also have Google Colab notebooks as well if you want to start playing around instantly, start copy pastoring. So we've got things like how do you connect the GDS Python client? How do you use the graph catalog, manage your in-memory graphs too, so you can get used to it and familiarized with it. It gives you information about the different algorithm execution modes. So you have like the estimator functions. Mutate allows you just to mutate what's in memory. Write allows you to actually write back to the instance. And there's stream if you want to take that data over the wire itself. As I said, memory estimation, algorithm progress as well. So you can check what's happening with those algorithms that you're running. How long is it going to take potentially? And you can also pick up the model catalog and sharing, which allows you to then say, hey, I've got many users on this instance. How do I share this model that I trained so that they can pick it up and use it themselves on predicting on new data? So the Python client is really, really cool. It allows you to natively interact with AuraDS itself. So you can treat AuraDS and all of the in-memory graphs and the models as Pythonic objects. So this means that you can then say, hey, either I want to run Cypher, or you might want to say, hey, gds.graph.list. And it's rather than adding lots of boilerplate and having to learn about transaction functions and everything else, you can just do this Pythonically and interact with AuraDS. So I mentioned hassle-free administration before. So we give you all the metrics within AuraDS as well. So what's your instance doing? Is the heap growing? Is the CPUs being like, are they screaming? What about snapshots? What happens if I want to take those ad hoc backups on demand so that I can then carry on and not have to worry about what's happening? You can migrate your databases instantly, and you can clone as well. And these are all enterprise-ready, fully managed instances, and we worry about the updates, the security patches for you, so you don't have to. So just to recap on the product features, scale up and down on demand, and you get access to really large hardware too for all your data science needs. You get all of the enterprise GDS features, plus access to all of the new GDS features as they're released. You get MLOps support, so it means you can persist, publish, and share those models between your users. And we automate all the operability. So what we do is when you're not running on the algorithms, we take that instance away. I say 5 minutes. It's actually on average about 1.5 minutes we do this for. We just quickly run all the updates. So new Neo4j, security patches, everything else is taken care for you. You can back up with one click in the UI, and very, very soon, hopefully, we'll have the backup API as well if you want to do that automatically. It's secure in flight, I mentioned TLS, and it's secure at rest as well. And you can pay any way you want. It's all based on consumption-based pricing. How many gigabyte hours are you using? And you can pause when you don't need it, so when you go home at night, and you can save 80% of the costs, and everyone's happy within your organization. So what's coming soon in 2022? Obviously, AuraDS Enterprise, we're hoping to launch that Q3. And then Apache Arrow support. You saw the Arrow demo today in the keynote. We just need a little bit of time to get that sorted out in the Auraverse. So we'll be hopefully launching that next quarter as well. And we're looking to do AWS as well, so that'll be Q3. So hopefully, fingers crossed, everything going well. You'll see all these 3 things out next quarter. And with that, I'm going to say thank you and keep it really, really short because everyone wants to probably leave by now. So thank you, guys. Any questions? That's awesome. No questions. Oh, I should have said, if you want to get in touch with me, Luke at Neo4j.com. Thank you very much, folks.